Good morning, everyone. Today I'll be presenting about the risk of air pollution from coal combustion and the recommended control strategies to reduce its effects. First, let's look at the risk of air pollution from coal combustion. Coal combustion releases harmful gases such as sulfur dioxide, nitrogen oxides, and carbon dioxide. These gases contribute to air pollution, acid rain, and greenhouse effect. Next, there's the health impact. When people inhale fine particulates from coal burning, it can cause asthma, lung cancer, and heart disease. This is especially dangerous for children and the elderly. Then, there are environmental effects. Air pollution from coal plants produces smoke and haze, which reduce visibility and worsen air quality. Lastly, coal combustion contributes to climate change because it releases a large amount of CO2. This increases the global temperature and causes more extreme weather events. Now, let's move on to the recommended control strategies. There are three main components that we focus on: the emission stack, ash disposal, and cooling water system. Firstly, emission stack using electrostatic precipitated (ESP). In this process, flue gas from the boiler first go through a dust collector using an ESP. The ESP removes dust and ash particles. Then the gas enters the flue gas desulfurization (FGD) system, which removes sulfur dioxide. After cleaning, the clean flue gas is released safely through the stack, while dry ash is collected and sent to the silo for disposal. Secondly, ash disposal using fabric filter system. Here, flue gas passes through a fabric filter which traps fine ash particles. The gas then flows into the FGD system for further cleaning. Meanwhile, the collected ash moves to a blow tank and then into a silo for safe storage and reuse. These methods helps reduce air contamination caused by fly ash. Lastly, cooling water system using flue gas desulfurization (FGD). In this system, flue gas passes through the ESP and then into an SO2 absorber where seawater helps remove sulfur compounds. The gas then goes back to reheat equipment before being released as clean flue gas through the stack. The used seawater is sent to a treatment plant before being discharged safely as treated water. This system reduces both air and water pollution. In conclusion, coal combustion has many negative impacts on human health, the environment, and the climate. However, by using technologies like ESP and FGD, fabric filters, we can significantly reduce harmful emission and create a cleaner, safer environment. Thank you.
Good morning everyone. Today I will be presenting about environmental filtering methods and how they relate to Sustainable Development Goal 7, which is affordable and clean energy. Let's start with the comparison between electrostatic precipitators or ESP and fabric filters. ESP are good for removing fine particles from flue gas, but they are less efficient when it comes to sticky dust. On the other hand, fabric filters are more efficient as they can remove even very fine dust and ash particles. In terms of cost, ESP has a high capital cost but low operating cost, while fabric filters are cheaper to install but more expensive to maintain. The ESP system is more complex, while fabric filters has a simpler mechanical design. Lastly, ESP don't produce secondary waste, whereas fabric filters generate solid waste that needs to be disposed of properly. Next, let's look at wet scrubbers and dry scrubbers. Wet scrubbers are highly effective at removing acidic gases and fine particulates. but they require more water, energy, and maintenance. This makes their operational costs higher because of pumping and sludge disposal. Dry scrubbers, in contrast, use much less water and are easier to operate, though they are less effective for very fine particles. In terms of environmental impact, wet scrubbers produce wastewater or sludge that must be treated, while dry scrubbers produce dry solid waste that's easier to handle and dispose of safely. Thirdly, these strategies also support renewable energy integration. We make power plants cleaner and more efficient. It becomes easier to transition to greener energy sources while keeping electricity reliable and affordable. This supports long-term energy sustainability. Lastly, there is a clear benefit to public health and quality of life. Cleaner emissions reduce air pollution, which means fewer respiratory diseases and lower healthcare costs. This improves living conditions for communities near power plants. So overall, these environmental filtering methods not only reduce pollution, but also help make energy production cleaner, more efficient, and sustainable, aligning perfectly with SDG 7. That's all. Thank you.